Creating a neural network in Pascal for image classification is simple. We start with the line, write-len, creating neural network. This command simply displays a message on the screen, indicating that the creation of the neural network is in progress. Next, we encounter nn receives tnnnet.create. This line initializes the neural network. It assigns nn to a new instance of the class tnnet. Now we move to the heart of the network, where we add layers with the line nn add layer. Each layer of a neural network is responsible for different aspects of data processing, and here we're adding a series of them to our network. The first layer is tnnet input, create 32, 32, 3, which sets the input size for the network. The parameters 32, 32, and 3 define the dimensions of the input data. Following this, we have a convolutional layer, tnnet convolution linear create 64, 5, 2, 1, 1. This layer applies 64 filters to the input data, each of size 5 by 5, with padding of 2 and a stride of 1. The last parameter, 1, indicates that bias suppression is active. The next layer, tnnet max pool create 4, is a max pooling layer with a pool size of 4. This layer reduces the spatial dimensions of the input, keeping the most important information. tnnet moving's normalization.create is the standard normalization layer. This layer normalizes the output of the previous layer to have a 0 mean and standard deviation of 1. We then add several convolution layers with the ReLU activation function. These are tnnet convolution ReLU.create 64, 3, 1, 1, 1. Each of these layers applies 64 filters of size 3 by 3 to the input, with padding and stride of 1. Output. Next up, tnnet dropout create 0.5 introduces a dropout layer. This layer randomly sets half of the input units to 0 at each update during training time, which helps prevent overfitting. Then there's another max pooling layer, tnnet maxpool.create 2, this time with a pool size of 2. The next layer, tnnet full connect linear create 10, is a fully connected layer with 10 neurons. This layer connects every neuron in the previous layer to every neuron in the next layer. Lastly, tnnet softmax create 1 adds a softmax layer. This layer converts the output of the previous layer into probability scores for each class, which sum up to 1. So, to summarize, we started by creating an instance of a neural network. We then added several layers, each with its own roles and parameters. These layers included input, convolution, pooling, normalization, dropout, fully connected, and softmax layers. Each layer contributes to the overall functionality of the neural network, allowing it to learn from and make predictions on the input data. And there you have it. That's how you create a neural network in Pascal for image classification. It's a fascinating process, isn't it?